Hello, hi, good afternoon, class. This is Mr. Brain. Today I want to lecture you on something very, very important. Alright? So I need us to look at this periodic table. It's a very, very interesting subject or topic in the chemistry, but some of us we don't have understanding of this thing. So I want to help you, okay? Now look at this periodic table. First of all, what is periodic table? When you hear the word periodic table, the first thing that comes to your mind is a table, all right, with all the elements. Are you getting me? Now listen, periodic table is not just a table with all the elements. It has a lot of history. All right. For instance, we have what we call the old periodic law. Now, in the old periodic law, the periodic table was arranged based on the atomic masses or atomic weight of all the elements. Are you getting me? So all the elements in the periodic table were arranged based on what? Their atomic masses. Are you getting me now? You understand what I'm saying? And the first person that set up a periodic table is Dimitri Mendeleev. Dimitri Mendeleev. Now, the spelling The spelling may vary depending on, author of any textbook. Are you getting me now? The periodic law then states that what? The properties of atoms are a periodic function of their atomic weight. You understand that? That is, atoms behave based on their weight. You understand that? Now, apart from that, we discovered that, or they discovered then that, while they were arranging those atoms, the properties of atom were not, consistent. Are you getting me? Now, they expected some group to have some certain behavior or similarity. It was not so. Are you getting me? So let's say element A, B, C, D, E, F, G, H. As they were arranging these atoms, eh, those atoms have some variation in properties. You understand what I'm saying? So that gives room for questioning what happened. And from questioning, they discovered that this atomic periodicity is not following the order of atomic weights. Are you getting me? That brings us to what we call the modern periodic law. Alright, so let's look at the modern periodic law. So what's the modern periodic law? In the modern periodic law, we are going to say that the new periodic table was designed based on what we call the modern periodic law. Please follow me. Modern periodic law. Modern periodic law. So what is this modern periodic law? Now we now discover that atom, the atomic property, eh, is a periodic function of atomic number. Atomic number. Take note of atomic number. I need to explain this very well so that you understand. What that means is that the behavior of atom follows the atomic number. You understand that? That is, atom behave with respect to atomic number. You understand what I'm saying? So that means that the modern periodic table was arranged based on atomic number, not atomic weight. So you must understand the difference now. Remember, the first periodic table was what? Arranged based on what? Atomic weight. Now the modern periodic table is arranged based on what? Atomic number. I hope you get that. You understand that? Alright, let's continue. Now, the next thing we need to look at is what we call the group and the period. Now, because we are talking about table, we should have rows, are you getting me, and column. Alright, so in the modern periodic table, we have 18 columns. So 18 columns, that is 18 groups. You understand me? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 to the 18th. Are you getting me? So there are different 18 columns which signify different groups. Are you getting me? Then we now have how many rows? We have 7 rows. We have what? 7 rows. So there are 7 periods. 1, 2, 3, 4, 5, 6, 7. So there are 7 what? Rows. Now, I know that some of you were taught by your teacher that we have 8 groups, not 18. So I need to explain that so that you understand why 18 and why 8. Now, what they call 8 groups is what we call group 1A, 2A, 3A, 3B, 3A, 4A, 5A, 6A, 7A, and 8A. So it was formerly AAA, Roman numeral 1A, Roman numeral 2A, alright, so we get to 8. So initially we had those transition elements, alright, that were, categorized as B. You understand? I get it. 1B, 2B, 3B, and so on and so forth. You understand me? So what we were formerly calling 8 groups was the 1A, 2A, 2B, I get it, to the 8. You understand what I'm saying now? So now, if we combine both the A and the B, the transition element and other elements, all of them fall into 18 groups. 18 what? Groups. I don't know if you understand. I know you understand what I'm saying now. 18 what? Groups. I remember how many periods we have? 7 periods. So now, the best or the most interesting aspect of this class is understanding what the groups is all about and what this period is all about. Are you getting me now? Now, mind you, every element in the same group has the same properties. There is something common in all the elements in the same group. So, let's say I have group 1, I have my hydrogen, lithium, I have my sodium, potassium, I have my cesium, francium. I think there's one more. Hydrogen, lithium, right? Sodium, okay, right? So now listen. All these elements have something in common. Francium, sorry. All these elements have something in common. And what is common to all of them? At the outermost energy level, they all have one electron at the outermost energy level. So those electrons are called valence electrons. Valence what? Electrons. So the electron you find at the outermost energy level is called valence electron. So what is energy level? Energy level has to do with the distance, in an atom we have the nucleus, right? Then the electrons are revolving around the atom. Okay? So the interval between the nucleus and the orbit or the space for the electron to revolve, that's what we call energy level. There are different energy levels. Alright? So the electron occupying different positions or different distance between the nucleus and that orbit has a particular amount of energy. You understand me? They have a particular amount of energy. So what that means is that the electron found here have different energy from the electron found here, and the electron found here, and the electron found here. Are you getting me now? So the energy level. You understand me now? So we have energy levels. So according to the number of electrons in the energy level, that is how these groups are designated, or the atoms in these groups are filled in or are arranged. You understand me now? So this ones you see me arranged here, they all have one electron in the atomose shell. I hope you understand that. Alright, so the ones that will be in group 2, they will have what? 2 electrons in the atomose shell. Like that. You understand what I'm saying? I hope you understand that. So now, these are metals, alright? These are also metals. And what are metals? Metals are those atoms that have valence electrons that could be, given out during ionization. So those electrons that can go out, that could be given out because metals donate their electron during ionization. That is during any chemical reaction at all at all. You understand what I'm saying? So they give out the electron. I hope you understand. So it is easier to give out this one electron. So that is why these metals are very, very reactive because it's very easy to give out one electron compared to this. The more the electron, the more the energy that is keeping them together. Are you getting me? So at this point, the energy to hold the one electron here is very low. Alright, that energy is called ionization energy. We're going to talk about this. Alright, so this class will be broken in session, but I need us to understand it. So the next thing I need you to understand is that the last group, which is group 18, contains all the atoms that the energy levels are filled up. So how do we know the amount of electrons that will be occupied by a particular energy level? How do we know? So I want to give you the formula that will help you. Alright? In some textbooks, they tell you that the energy level is given as the number of electrons in an energy level is given as 2n raised to 2, right? Some textbook, right? Fine, no problem. But I want to give you a formula that will help you. So the first energy level has 2 electrons. The second energy level has 8 electrons. 8, then we have 18, we have 18, then we have 32. I'll stop here. Alright? At least this one will help you to cover the most common atoms. Alright? So when you are doing electronic configuration, alright, this is the pattern you follow. So let me take an example. Calcium. This is calcium. Calcium is atomic number 20. So I will configure all these 20 electrons into this pattern. So the first energy level will have 2 electrons. How many electrons remain? 18. So the 18 will move to the next energy level. So we have 8 electrons. How many remain? 10. The 10 will move to the next one. We have another 8, right? Then the remaining 2 will move to the next one. You understand? So therefore, you now have what? Remember, this is 2 plus 8, 10 plus 8, 18 plus 20. So the 20 electrons. So how many energy level did this electron occupy? The first, the second, the third, and the fourth one. So remember, this is the outermost electron. And this outermost electron is called valence electron. It's called what? Valence electron. Now, which group does calcium belong to? Calcium belongs to what? Group 2. Because the number of electrons in the outermost shell is what? 2. You understand that now? Which period does it belong to? It belongs to period 1, 2, 3, 4. 4. It has 4 energy levels. So it belongs to period 4. So calcium will be in this period. Alright, calcium is supposed to be somewhere. And it also falls in. Alright, coincidentally. You understand me? So period 4, group what? 2. I started, learning table and I want to continue. Now, what you want to learn is how to configure atoms, the electronic configuration of atoms. What you want to know is how to put all those atoms, all your atoms in all their groups, especially those atoms beyond the first 20 element, right? So we're going to learn that now. Like I said before, now, the formula I'm going to give you, that, we have 2 types of electronic configuration, right? Now, okay, so for instance now, let me start with nitrogen, okay? So, nitrogen is atomic number 7, alright? We can quickly do an electronic configuration based on the principal energy level, right? Principal quantum number, right? So, which is what? 2 and 5. You understand? 2 and 5. So this is the principal quantum number. Or we can do the SPDF electronic configuration, right? So let's do the SPDF. So we have 1s2, right? 2s2, 2p what? 3. Can you see that? Right? So now, I won't be focusing on this for now. Okay? Alright? I won't be focusing on this for now. Maybe that will be for some other time. My focus is this. Alright? This one is more important now. Alright? So in the next class, I'll do that. So let's focus on the first energy level, which is the principal energy level. We have 4 quantum numbers, right? We have principal quantum number, secondary quantum number, you have your spin quantum number and magnetic quantum number. Alright? Okay, so now, for instance now, Let's say we have atomic number 21, which is what? Scandium, right? Scandium 21. How do you configure it? What group does it belong to? And what period does it belong to? Okay, now let's do that. Now, remember, I gave you a formula and I said 2, 8, 8. The first energy level has 2 electrons maximum. The next energy level will take 8 electrons maximum. The next one, 8 electrons. The next 18, and we have 18, then I'll stop at 32. Okay? Alright? So now this is the first energy level, which is K, L, M, N, O, P. Alright? So now let's do electronic configuration of scandium. Right? So scandium, we have 2 first energy level go, 2 electrons. How many is remaining? If you take 2 away from this, you still have 19. So the next one is 8. The next one is what? 8. Right? And the next one is what? So this is 18, right? How many is remaining? 3, right? So the next one is 3. That is 21. Wow. 21. So that means that scandium belongs to period what? 1, 2, 3, 4. Period 4. Period 4. Period 4. And group what? It belongs to group what? 3. This is group 3. That is, sorry. This is not group 3. This is group 3A. Sorry. Group, I'll say group 3B. But listen, I need to explain this. Now, this is where the thing gets interesting. Now, remember, I told you about we have 18 groups, right? Good. So, before the 18 groups, we used to have 8 groups, which is 1A, 2A, 3A, and now to 0. Are you getting me? Remember, group 0 or group 18, they are both the same. Okay? Are you with me? They are both what? The same. Group 0 or 18. That is what? The group for those atoms that have complete what? Energy level. Alright? So the one that has this complete is what? Is in group 18. The one that has this complete is in group 18. You understand me? Let me give you an example. You have your helium. Helium is atomic number 2, so you just have 2, so it's in group 18. You have your argon. Okay, let's do neon. Neon is atomic number 10. It is what? 2 and 8. Can you see? 2, 8, so it's complete. Like, the last electron is completely filled. They belong to group 18. That's the way we're going. Now listen. What group does scandium belong to? Scandium belongs to group 13. Wow, group 13. Mr. What are you talking about? I don't understand. Explain this to me. Now let me explain. Okay. So remember I said we have group what? 1, 2, that's 1A, 2A, then it now comes to what? 3A. Are you with me? Then 4A, 5A. Are you getting me? Down to what? 6A, 7A, and then 8 or 18 or 0 or whatever. 8, 18 or 0. This is group 0. Are you with me now? Now listen. This is what you call your initial group 1, 2, 3, 4, 5, 6, 7, 8. That's the initial. One of these space, what happens in this space? There are other groups here, which is the group 1B, 2B, and all that. Alright? So when we combine all these groups, everything falls into group what? 18. You understand? Everything falls into 18 groups. Are you with me now? So all this one here is what makes up for the other transition element or other element. Are you getting me? Alright? So now watch. This is my group 1, 2. Then I have my 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright? Then this is my 13. Alright? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 13, 14, 15, 16, 17, 18. So remember, this your 13 is formerly group 3, the one you call group 3. Group 3 or Group 3 or what? 3A. Everybody understand now. Wow. Yeah, that's it. So your group 3 or 3A is like your group 13. So what that means is that all those ones that have 3 electrons in the atomic shell, eh? 3 electrons in the atomic shell are supposed to belong to what? Group what? 13. You understand now? So this scandium is supposed to belong to what? Group 13. So it's supposed to be a group 13. Now the next question is scandium. Is it a transition element or not? Remember we said all the groups here, the groups that are missing here, that's the 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All the groups here are for group, what do you call it, transition element. I'm going to explain transition element, alright? Now, all those ones are for transition element. Is scandium part of transition element? Yes, that's the first element in the transition series. So, scandium should go to is what? Group 3. So, scandium will be here. Why? Because it's transition element. Meanwhile, if it is not transition element, it's supposed to belong to what? Group 13. You understand that now. Let me give you an example. Aluminium. Let me write it here. Aluminium. I hope you can see my aluminium. Alright, yes. Now, aluminium is atomic number 13. So let's do electronic configuration of aluminium. That's what? 2, 8, and then 3. So, can you see this one has 3 electrons? And this one also has 3 electrons in the valence shell. Alright? Valence electron 3, valence electron 3. Are they in the same group? Are they in the same group? Answer the question. They are not in the same group. Why? Because scandium, which is supposed to belong to this group, is what are those, is at those transition elements. You understand me? It belongs to the transition element, so it will enter the group 3. Or, or what? You can see, right? Good. Now, meanwhile, aluminium is not a transition element. It's just a simple metallic element. So it belongs to the boron family. Okay, that's group 13. Boron family. So you see why aluminium is in group 13 and scandium is in group 3. You already understand that. That is how you do for every other element. Are they transition element or not? And you know how to fix them. I hope you understand. So I'll give you a work. Try this. Try do for other elements like your zinc. Try and do for chromium. Try do for phosphorus. Try do for chlorine. And then 1, 2, 3, 4. Then we'll now do for I'll take yttrium, YP, yttrium, the element yttrium. Atomic number withheld. You get the atomic number and do electronic configuration. Don't look at it. All you need is just find out the atomic numbers and do electronic configuration. Of course, with your instinct, you should know those ones that are common and those ones that are not, that are belong to the transition element. Alright? So in my next video, I'm going to tell you what transition element is and all that. Then we'll discuss further. Thank you.